Four black fins cut through the water. They are moving side by side. Same speed, same direction. No panic, no wasted motion. Ahead of them, a seal is resting on a small sheet of ice. For a moment, it looks safe. Then the orcas dive. A few seconds later, all four rise together and push a wall of water toward the ice. The wave hits hard. The ice tips. The seal slides closer to the edge. But the orcas are not done. They circle back, line up again, and create another wave. This time, the seal falls into the ocean. The hunt is over almost instantly. At first, it looks like a display of raw power. Four massive predators against one small animal. But that is not what makes this moment so unsettling. The real weapon is coordination. Every orca has a position. Every movement happens at the right time. One mistake could give the seal a chance to escape. But no one breaks formation. No one moves too early. Think about that. If strength was all that mattered, why would four animals weighing several tons each need to work together with such precision? Why not simply rush the ice? Because the ocean does not reward power alone. Being larger helps. Speed helps. Sharp teeth help. But none of those things guarantee control. The animals that survive here are often the ones that know when to wait, when to move, and when to rely on others. That is what makes the Pacific so different from the world we imagine. We like to believe the biggest predator rules everything. We assume the fastest hunter always wins. We look at teeth, muscle, and size, then decide which animal belongs at the top. But the ocean does not work that way. An orca can defeat prey through teamwork. A great white can succeed through patience. An octopus can survive by changing its body. A school of tiny fish can move like one enormous creature. Each one has found a different answer to the same problem. How do you stay alive in a world where almost everything is trying to eat, escape, hide, or outsmart something else? That is the real story of the Pacific. Not a simple battle between strong and weak. It is a battle between strategies. And sometimes, the most dangerous creature in the water is not the one with the biggest body. It is the one that understands exactly what the others are going to do next. Before we talk about the animals, we need to understand where they live. The Pacific isn't just another ocean. It's a world of its own. It covers more of Earth than any other ocean. You could travel for days and still see nothing but water in every direction. From the surface, it can look calm, quiet, even peaceful. But don't let that fool you. Beneath that surface is one of the most extreme places on the planet. The Mariana Trench drops so deep that sunlight never reaches the bottom. Down there, the pressure is almost impossible to imagine. It's a place that feels more like another planet than part of our own. Then there are the thousands of islands scattered across the Pacific. Some are tiny. Others support entire ecosystems found nowhere else on Earth. Every one of them tells a different story. Around the edges of this ocean sits the Ring of Fire, where earthquakes and volcanic eruptions happen more often than anywhere else. The ground itself is constantly changing. Even the ocean floor is never truly still. And in the Western Pacific, there's the Coral Triangle. It's often called the most diverse marine ecosystem on Earth. Life is everywhere. Big predators, tiny reef fish, strange creatures that seem almost impossible to believe. This isn't just a beautiful place. It's one of the toughest environments on the planet. Every day is a competition. Every meal has to be earned. Every mistake can be your last. That's why the Pacific creates animals unlike anywhere else. Some survive because they're stronger, some because they're faster, others because they're smarter, more patient, or simply better at adapting. As we go deeper into this story, you'll see something interesting. None of these animals became successful by following the same path. Each one solved the challenge of survival in its own way. And that's what makes the Pacific so fascinating. It's not just the biggest ocean on Earth. It's the ultimate testing ground for evolution. If you spend enough time watching orcas, one thing becomes obvious. They almost never hunt alone. That might sound strange at first. An adult orca is already one of the most powerful predators in the ocean. It's fast. It's massive. It has the strength to overpower animals much larger than itself. So why work as a team? Because for orcas, family is their greatest advantage. Every pod is built around a matriarch, usually the oldest female. She's more than just the leader. She's the one carrying years, sometimes decades of experience. She knows where to find food, when to move, and how to handle different situations. That knowledge doesn't disappear. It gets passed down. From grandmother to mother, from mother to calf. That's how an orca family grows stronger with every generation. What's even more interesting is that not every orca hunts the same way. Some pods spend their lives chasing fish. Others specialize in hunting seals, sea lions, and even whales. Offshore groups are known for going after sharks. They're all the same species, but they don't all live the same life. Researchers have even found that different pods have their own calls. In a way, it's like hearing different accents, or even different languages. Orcas from one family don't always sound like orcas from another. And their hunting techniques are just as unique. You've already seen wave washing. Several orcas create a powerful wave together to knock a seal off a piece of ice. That isn't something a young calf is born knowing. It has to be learned. Another incredible strategy is called carousel feeding. The pod circles a school of herring, slowly forcing thousands of fish into a tight ball. Once the fish are trapped, the orcas take turns striking the school with their tails. One hit can stun dozens of fish at once. No one rushes in. No one breaks formation. Every move has a purpose. Young orcas don't just watch these hunts. They practice them. Mothers sometimes let injured prey escape on purpose so their calves can learn how to finish the hunt themselves. Think about that for a second. They're not just feeding the next generation. They're teaching it. That's probably the biggest reason orcas have stayed at the top for so long. It isn't because one animal knows everything. It's because the family never lets that knowledge disappear. Now let's look at a predator that's almost the complete opposite of an orca. The great white shark doesn't depend on a family. It doesn't hunt in teams. And it doesn't need anyone to teach it what to do. Most of the time, it's alone. But being alone doesn't make it less dangerous. In some ways, it makes it even more impressive. A great white doesn't waste energy chasing everything it sees. It waits. It stays below the surface where the water is dark and quiet. From there, it watches. When the right moment comes, everything happens at once. It explodes upward with incredible speed, sometimes launching completely out of the water. The attack lasts only a second, but that second is usually enough. What makes this even more amazing is that the shark isn't relying only on its eyes. Hidden around its snout are tiny sensory organs that can detect weak electrical signals. Every heartbeat, every muscle movement. Even if a fish is buried under the sand, the shark can still sense that something is alive below. It's like having a sixth sense. Then there are the teeth. People often think a great white has the perfect set of teeth, but the truth is even more incredible. It never has to keep the same ones for long. As teeth break or fall out, new ones move forward to replace them. Over its lifetime, a great white can grow and lose thousands of teeth. Nature keeps rebuilding its most important weapon. But here's something many people don't realize. The great white isn't just a hunter. It also helps keep the ocean healthy. It usually targets animals that are weak, injured, or sick. By removing those individuals, it helps keep prey populations stronger over time. It's one of the reasons healthy oceans still need great white sharks. Everything about this animal feels incredibly refined. Millions of years of evolution have shaped it into a predator that doesn't need complicated plans or backup. Its body already knows what to do. The orca succeeds because knowledge is shared. The great white succeeds because instinct has been perfected over an unbelievably long time. But that raises an interesting question. What happens when perfect instinct comes face to face with an animal that doesn't rely on instinct alone, but on planning, teamwork, and experience? At first glance, hammerhead sharks almost look like a mistake. That wide, flat head doesn't seem like something that should work. But the longer scientists studied it, the more they realized it might be one of the smartest designs in the ocean. That strange shape isn't there to make the shark look different. It's there to help it find food. Spread across that broad head are thousands of tiny sensors that can pick up weak electrical signals from other animals. Even if a stingray is completely buried under the sand, the hammerhead still knows it's there. Its eyes are pushed far apart, giving it a wider view of what's happening around it. Instead of searching harder, the hammerhead simply senses more. It experiences the ocean in a way we never could. Then the story takes a surprising turn, because not every giant fish became successful by becoming a better hunter. Take the whale shark. It's the biggest fish alive today. Some grow longer than a school bus. Looking at one, you'd expect it to be one of the ocean's most terrifying predators, but it isn't. A whale shark doesn't chase seals or attack whales. It swims slowly with its enormous mouth open, filtering tiny plankton, fish eggs, and small fish from the water. That's it. No giant teeth, no powerful bite, no dramatic attacks. Its size does something completely different. Small fish often swim alongside it. Remoras attach themselves to its body, feeding on scraps, while staying protected from other predators. Without even trying, the whale shark becomes a moving shelter for other marine life. I think that's one of the most interesting things about the ocean. Two massive animals. Two completely different solutions. One turned its body into an incredibly sensitive radar, able to detect prey hidden out of sight. The other turned its massive size into a peaceful, floating ecosystem where smaller creatures can survive. Neither strategy is better. They simply prove there's more than one way to become successful in the ocean. If there was ever an animal that completely changed the way I think about intelligence, it's the octopus. The first time you learn how its nervous system works, it almost doesn't make sense. Most animals, including us, rely on one brain to make decisions. An octopus doesn't work that way. A huge portion of its neurons aren't even in its brain. They're spread throughout its 8 arms. That means each arm can sense, react, and solve simple problems on its own without waiting for instructions from the center. It's less like one brain controlling 8 arms and more like 9 parts, constantly working together. Then there's its ability to disappear. An octopus doesn't just change color. It changes patterns. It changes texture. 1 second it looks like a rock. A moment later, it blends into coral, sand, or seaweed so well that predators can swim right past without seeing it. Some species take it even further. The mimic octopus doesn't simply hide. It pretends to be something else. Depending on the danger, it can copy the shape and movement of animals like sea snakes, lionfish, or stingrays. It's not repeating the same trick every time. It adapts to the situation, and that's what makes it so remarkable. It can also solve problems in ways most people wouldn't expect from an animal with such a short life. Researchers have watched octopuses collect coconut shells, carry them across the seafloor, then put the pieces together later to build a shelter. That's planning ahead, not reacting, planning. Its body is just as unusual. Instead of 1 heart, it has 3. Instead of red blood like ours, its blood is blue because it uses a different molecule to carry oxygen. And because its body has no bones, the only hard part is its beak. If that beak fits through an opening, the rest of the body can squeeze through spaces that seem impossibly small. But honestly, none of that is what stays with me the most. The part I can't stop thinking about is the mother. After laying her eggs deep inside a safe den, she stays there to protect them. She keeps fresh water flowing over the eggs. She chases away anything that comes too close. And she doesn't leave. She doesn't hunt. She doesn't eat. She spends everything she has protecting the next generation. By the time the eggs finally hatch, she's too weak to survive. Her job is finished. Her young swim away into the ocean alone, and she'll never see what they become. That's hard to forget. For an animal that usually lives only a year or two, every day matters. Maybe that's why the octopus seems to make every moment count. It doesn't have a long life. It just uses the life it has incredibly well. After learning about the octopus, you might think nothing in the ocean could surprise you anymore. Then you meet the jellyfish, and suddenly, everything you thought you knew about intelligence starts to fall apart. Think about it. A jellyfish has no brain, no heart, no blood. Its body is almost entirely water. By our standards, it shouldn't be one of the ocean's greatest success stories, and yet it is. Jellyfish have been here for more than 500 million years. They were drifting through the oceans long before dinosaurs ever existed. They've survived mass extinctions that wiped out countless other species. That's hard to ignore. Their bodies are incredibly simple, but they're built to do exactly what they need. Some species glow in the dark, using bioluminescence. In the deep ocean, where sunlight never reaches, that living light can attract prey or warn off predators. Others rely on thousands, even millions, of tiny stinging cells packed into their tentacles. The amazing part is how fast those cells work. They fire almost instantly. No thinking, no planning. Just a response that evolution has refined over hundreds of millions of years. Then there's one jellyfish that almost sounds like science fiction. Scientists call it the immortal jellyfish. When it's injured, stressed, or reaches old age, it can do something almost unbelievable. Instead of continuing toward death, it can reverse its own life cycle. Its adult cells transform back into younger cells, and the animal begins growing again from an earlier stage of life. It's not really cheating death forever, but it is starting over in a way that almost no other animal can. The more I think about jellyfish, the more they challenge the way we define intelligence. Maybe intelligence isn't always about solving problems or having a bigger brain. Maybe it's also about finding a design that works so well it barely needs to change. For over 500 million years, jellyfish have done exactly that. So here's the question I keep coming back to. Have we been defining intelligence too narrowly by assuming every truly successful animal has to have a brain? Not every dangerous animal uses its power the same way. That's something the ocean makes very clear. Take the banded sea crate. Its venom is incredibly powerful, strong enough to kill a human if it ever decided to bite. But here's the surprising part. It almost never does. Divers have swum right beside these snakes without any problem. They're calm. They don't waste energy attacking things they don't need to attack. When night falls, they quietly move through coral reefs, searching for small fish hidden in narrow cracks. One quick, accurate bite is usually all it takes. That's it. No unnecessary fights. No showing off. It has one of the deadliest weapons in the ocean, but it uses that weapon only when it actually matters. Then you look at the lionfish, and it's a completely different story. The lionfish is covered with venomous spines, but its real advantage isn't just its venom. It's how quickly it spreads. In places where lionfish don't have natural predators, their numbers explode. They reproduce over and over, consume huge amounts of native fish, and slowly throw the entire ecosystem out of balance. What was once a perfectly adapted predator becomes an invasive species capable of changing an entire habitat. That's the difference. The sea crate has incredible power, but nature still keeps it in balance. The lionfish shows us what can happen when those natural limits disappear. I think there's a bigger lesson here. Power by itself isn't dangerous. Power without boundaries is. In nature, every predator evolved alongside prey, competitors, and challenges that kept everything in balance. But when that balance disappears, survival stops being the goal. Destruction takes its place. And sometimes, that's far more dangerous than venom itself. By now, we've seen predators survive with strength, speed, venom, and intelligence. But some of the ocean's most successful animals do something completely different. They survive by almost disappearing. Take the leafy sea dragon. The first time you see one, it doesn't even look like an animal. It looks like a piece of drifting seaweed. And that's exactly the point. Those leaf-like extensions aren't there to help it swim. They're there to make it invisible. It doesn't chase prey. It doesn't fight larger predators. It simply blends into the kelp so well that most animals never notice it's there. Honestly, that's an incredible strategy. Sometimes the safest fight is the one you never have to enter. Then there's its close relative, the seahorse. It might be one of the strangest fish in the ocean. Instead of swimming horizontally, like almost every other fish, it swims upright. Its curled tail wraps around seagrass or coral, keeping it steady while the current moves around it. It doesn't rely on speed either. It relies on patience. One of the most surprising things about seahorses has nothing to do with how they swim. It's how they raise their young. The male carries the eggs inside a special brood pouch. He protects them until they're fully developed, then releases hundreds of tiny seahorses into the water. It's one of the few examples in nature where the father takes on the pregnancy. That alone makes them remarkable. When I look at animals like the leafy sea dragon and the seahorse, I think they remind us of something important. The ocean doesn't only reward animals that can overpower everyone else. It also protects the ones that know when to stay hidden. Sometimes surviving isn't about winning every fight. It's about avoiding the fight completely. And in a place as unpredictable as the Pacific, that may be one of the smartest strategies of all. Now let's talk about one of the smallest animals in this story. A single sardine isn't impressive. It's small. It has no sharp teeth, no venom, no armor. On its own, it's one of the easiest meals in the ocean. But that's the key. A sardine almost never lives on its own. Instead, millions, sometimes even billions, move together in one enormous school. Watching it happen is almost unreal. The entire group turns at the same moment, changes direction instantly, and flows through the water as if it were one giant animal instead of millions of tiny fish. What's amazing is that there's no leader. No fish is giving orders. No one is in charge. Each sardine only pays attention to the few fish closest to it. Along both sides of its body is a sensory system called the lateral line. It lets the fish feel tiny changes in water movement and pressure around it. That's all it needs. One fish reacts. The next fish reacts. Then another. That simple chain of reactions spreads through the entire school in an instant. When predators attack, the sardines tighten into what's called a bait ball. From the outside, it looks like a giant silver sphere spinning through the water. Inside, every fish keeps moving. Every position changes constantly. For a predator, it's almost impossible to focus on one target. The school becomes confusing, overwhelming. It's one of the best defenses in the ocean, and it works without anyone being in control. What's even more important is the role sardines play in the Pacific. They're not just trying to survive. They help countless other animals survive too. Whales depend on them. Dolphins hunt them. Sharks feed on them. Take sardines out of the food chain, and the entire system begins to fall apart. I think that's what makes them so fascinating. Not a single sardine understands the movement of the whole school. But together, they create something far bigger than any one fish could ever become. Sometimes, intelligence isn't about one individual knowing everything. Sometimes, it's about thousands or even millions following simple rules so well that they become one living system. After everything we've seen so far, you might think the ocean has already shown us every kind of intelligence. Then you watch dolphins, and suddenly, it feels much more familiar. One of the first things scientists noticed is that every dolphin has its own signature whistle. It's not just a random sound, it's unique to that individual. In a way, it's like having a personal name. When one dolphin uses that whistle, another dolphin recognizes it and responds. Mothers and calves use these calls to find each other, even when they're separated. That alone is incredible. But it gets even more interesting. When researchers placed a mirror in front of dolphins, they didn't react as if they were seeing another animal. Instead, they examined themselves. They turned their bodies, looked at marks on their skin, and even opened their mouths to inspect what they saw. Very few animals can do that. It suggests they're aware of who they are. Dolphins also experience the world in a way that's hard for us to imagine. They use echolocation, sending out clicks and listening to the echoes that bounce back. From those echoes, they can tell where something is, how big it is, how fast it's moving, and even get clues about what's inside it. It's almost like seeing with sound. And they don't just rely on instinct. Some dolphins have been seen carrying sea sponges on their snouts while searching for food along the seafloor. The sponge protects their sensitive noses from rocks and sharp coral. What's amazing is that this behavior isn't random. Mothers teach it to their daughters, and those daughters pass it on again. Knowledge keeps moving from one generation to the next. Dolphins also spend time doing something many animals rarely do. They play. They ride waves. They chase each other. They toss seaweed back and forth for no obvious reason other than enjoyment. And when one member of the pod is injured or too weak to reach the surface, the others don't leave it behind. They help lift it up so it can breathe. The more you learn about dolphins, the harder they are to describe with simple words like smart. They don't just solve problems. They build relationships. They teach. They cooperate. They recognize themselves. Maybe that's what makes them so remarkable. Dolphins don't just know where they are in the ocean. They seem to know who they are within it. After looking at all these incredible predators, it's easy to think survival is all about strength or intelligence. Then you watch a sea turtle, and the story feels completely different. Sea turtles have been crossing the oceans for more than 100 million years. Long before humans. Long before most of today's marine animals even existed. Every year, they travel thousands of miles across the Pacific. They cross open water with no roads, no landmarks, and no map that we can see. Yet somehow, they find their way. The most amazing part comes years later. After spending most of their lives in the ocean, female sea turtles return to the very same beaches where they were born. Scientists are still trying to fully understand how they do it, but somehow they remember. Late at night, the mother slowly crawls onto the sand. She digs a nest, lays hundreds of eggs, carefully covers them, and quietly disappears back into the ocean. Her job is done. Weeks later, tiny hatchlings begin digging their way to the surface. The moment they emerge, the race begins. They're only trying to reach the water, but those few yards may be the hardest journey of their entire lives. Birds are waiting overhead. Crabs are waiting on the beach. Larger fish are waiting just beyond the shoreline. Most of them won't survive. Only a small number will ever grow into adults and make that same journey back one day. And today, the challenge is even greater. Plastic pollution, disappearing nesting beaches, and accidental fishing nets have made survival harder than ever. Watching sea turtles reminds me that not every lesson in nature comes from a predator. Sometimes the greatest lesson comes from endurance. Some journeys aren't learned in a single lifetime. They're passed down across generations, carried by instincts that have survived for millions of years. Maybe that's the most remarkable memory of all. It isn't stored in one animal's mind. It's carried forward by an entire bloodline that refuses to forget. After everything we've seen, I don't think the biggest lesson is about which animal is the strongest. It's that there isn't just one way to survive. The orca reminds us that knowledge becomes more powerful when it's shared. The great white shows what millions of years of instinct can create. The hammerhead proves that sometimes the best weapon is simply sensing the world differently. The octopus survives because it never stops adapting. The jellyfish has lasted for over 500 million years by following one of evolution's simplest designs. The sardine teaches us that millions of small individuals can become something no predator can easily overcome. The dolphin shows us that intelligence isn't only about solving problems. It's also about relationships, learning, and understanding yourself. And the sea turtle reminds us that some journeys are so important they're carried across generations. When you put all of these animals together, something becomes clear. The Pacific isn't ruled by one perfect predator. It never was. Every species we've talked about found its own answer to the same question. How do you survive in one of the most demanding places on Earth? Some became faster. Some became stronger. Some learned to work together. Some disappeared. Some adapted. Some simply endured. That's why the Pacific feels so extraordinary. It's not a place where one winner stands above everyone else. It's a place where millions of different solutions have survived side by side for millions of years. And maybe that's the biggest lesson the ocean has to offer us. Nature doesn't reward one perfect design. It rewards the designs that never stop working. If you enjoyed exploring these incredible animals with us, subscribe to Predator Archives. The ocean's greatest predators and its most extraordinary survivors still have countless secrets that science is only beginning to understand. We'll see you in the next adventure.